Okay, so welcome you all to week 11 of Learning Analytics Tools course. And today we will be focusing on content of week 11. Yeah. So in week 11, the lecture focus was mostly on multimodal and multi-channel data analytics. So we have actually completed all the descriptive analytics and diagnostic analytics, then predictive analytics. So all that steps we have done. So now one thing which we need to understand, which is very specific to data analysis with respect to learning environment or learners, is that the data collection is not just limited to the classroom observations or the log data. There are other ways to capture other related data, and that will help us in coming to conclusions or form varied research questions for our studies. So one such important aspect of is my voice audible? Because I can still see your good evenings in the chat box where I have already started speaking. Am I audible? Okay, great, thank you. Yeah. So we'll continue about multimodal data. So multimodal is where we capture different modes of data collection. So many of the times that is also referred to as multi-channel, because it is captured through different sensors, and different sensors are focusing on different data. So here this list is from week 11's lecture, where the different sensors and what they are actually capturing. So this column is all the sensors, and this is what data is getting captured, or data which is being captured. Yeah. So EEG, or electroencephalography. Okay, so even I get confused with the full form, so because we generally use this term EEG. So what EEG sensor has, it has the small electrodes which learner or a user have to wear like a cap, or it's a band which will go across your head, and those electrodes will capture brain waves. So many of the times EEG is the sensor which can be used for the medical diagnosis purpose as well. Okay, but for like for learning analytics study, the focus on brain waves is to capture cognitive load, how much your brain is under stress, and their engagement and such things. Then for emotion detection, so mostly this is the upcoming area in the field of learning analytics, where based on the facial expressions, based on the data from web camera, how emotions are detected, or affect detection, or affective computing, that is happening based on the webcam's data, the video data, the frames which are getting captured every minute. So every frame will be analyzed for facial expressions, like there are different actuation units, like what is the eyebrow movement, what is the lip movement, then is it smile, is it the white smile, are teeth showing, and all such things are considered to detect different emotions of learners while they interact with the learning environment, or while they learn. Yeah. So that is affective computing, or facial the emotion detection through facial expressions. Then obviously the most common thing is using microphone to capture the voice data of the learners while they are, so mostly this is used to capture the classroom discourse, or to analyze the degree of collaboration happening in collaborative learning. So for all those purposes, we need to capture what is being said by different team members in a team, or by teachers and students, the conversation between teachers and students. So all those factors are getting captured and then transcribed, and then the text is analyzed. So when we saw NLP, we saw the tone detection or emotion detection is also possible when we analyze the text. So all that becomes one channel of the data. The spoken when converted to text can be analyzed as well. Then wall-mounted biological sensors, there are different array of sensors. This area is very less explored. So in the classroom, maybe there would be set of cameras, or the movement detection cameras, the heat detection cameras. So all such things which can be wall mounted to detect the posture or to detect the stress level in the student. So all, and that data can be analyzed further from learning analytics point of view. Then another favorite of in the field of learning analytics is the eye tracker data, which captures the eye gaze, pupil dilation, and such things. So that is detected to track the eye movement in the screen, where where the learner is looking at, and that is mostly used to improve the quality of teaching and learning. Where exactly in a learning environment, where exactly on the screen a particular student is paying more attention to, whether they are paying more attention to a particular diagram from that particular page. So we can detect which part are difficult to grasp for the learners, and then that information can be used to improve the learning outcomes. Then skin conductance is galvanic skin response, that is GSR. So when we are under stress, or when we are emotionally aroused for a certain emotion, then at that time our skin sweats, or the body temperature changes. So those changes are captured by this GSR sensor, and then we can analyze those sensors for the particular emotion which is undergoing, by which a learner is undergoing. Yeah. So then Kinect is another sensor which is generally, like, most commonly used in learning sciences, is the Kinect chairs, where the pressure sensitive chairs. So as we make as you know, as we read something, or as we are engaged, or as we get frustrated, we change our body postures very often. So that changes the pressure points on the chair where we are sitting. So through the different the variation of pressure which is getting applied to that particular chair, so we detect the learner emotion or the stress and further things. So that is part of the Kinect. So this was the background about the different channels of the data collection. So why? 1 second, I think this is not. Yeah. So another so we briefly discussed affective computing. So mainly affective computing is detecting the human emotions, and the it doesn't stop only at the detection. So after detecting certain features, we need to interpret what kind of emotion is emoted by the learner or the our subject, and then we need to analyze and analyze that for why this thing has happened, and or what will be the implications of that things. And mostly the simulation of those human emotions are done by the this discussion is with respect to computer based learning environment, where there are no humans involved in teaching process. So at that time there are learning agents. So these agents can then simulate the emotion which a learner is going through at a particular point. So if they are frustrated, then to motivate them, the particular emotion could be emoted by that learning agent. So, or if they are happy with the correct answer, by answering a question correctly, then this learning agent would reply very happily that, okay, you did it, very good job, move ahead. So something like that. So the whole affective computing is not just limited to detecting the emotions, or identifying a correct emotions, or that is the identification part, is like interpreting that recognized features, and kind of mapping it to the a particular emotion, like through facial expression. So recognition would be change in facial expression, like eyebrow movement or the lip movement, and etc. And then we need to interpret that thing and then link it to a particular emotion, a particular this particular eyebrow raise or a large smile is associated with happiness, or drooped eyelids, and lips pursed together is associated with sadness or frustration, so all such mapping has to be done. Then that means we are interpreting the features or the way the body language of the learners, and then we have to analyze the background, like on which page were there with respect to computer based learning environment and how those things were happening. And then in the next phase we need to act upon our information. When we have deduced that a learner is getting frustrated because he's not able to answer any question particularly correctly, then our through our learning agent we need to prompt the learner to either revisit a particular chapter or go through that topic again, and so on. So how do we measure affect or emotional state? So there are different ways which are listed here through different set of sensors like EEG, then EMG, then GSR, or the text. Through the textual data also we can do the emotion detection, and of course the multimodal data analysis, where all the different modes of data are considered together, and different modes like text data with the facial expressions data, with the speech, what they are speaking, the posture or body language. So all these things combined together, we can use it to detect the emotional state or affect. Now eye movements and pupils are also, like when particular eye movement is happening, that will be corresponding to a particular emotion. So even the eye tracker or that eye movement will also be helping us to detect the emotion. So now another important point to note here is Dr. Paul Ekman, he conducted a cross-cultural research in 1960, where he thought there has to be some universal way to show emotions. So he concluded that all human beings show their emotions in a same way, in similar manner, the happiness, sadness. So he listed down some basic emotions. So some of the basic emotions listed here are anger, disgust, fear, happiness, and sadness. So these are the basic emotions which we can detect in a learner through all these data which are listed here in this slide, using different modes of data or different channels of data. So even nowadays, apart from these data, even the sensorless affect detection, I mean, just through the log data or by manual human observation, that is also picking up speed in the field of learning analytics. There are many research studies which are reporting, just using log data and human observations, how there is a strong link between the actions performed by the users and their emotions, their current emotional state. So that study is also picking up the speed. Now coming to eye tracking, so there are different eye trackers which will kind of detect your pupils, and then they will track the pupils, how you are moving your pupils when you look at different parts of the screen. Yes. Yes, pupils can be tracked, exactly. So you need to calibrate your eye trackers. You need to first, I mean, just, it's not like place your eye tracker and it will start capturing. So you need to specify your screen size before you calibrate for a particular user, and for each user, for each session, you have to calibrate your eye tracker. You have to tell them, we have to first adjust our face in such a way that our pupils or our eyes are matching into the diagram which is shown on the screen. So that way, for the first point, the starting point, the sensors know where our eyes are, where our pupils are, and then they would give the corner points at the four corners of the screen, and then you have to look at those four corners of the screen in the sequence which is mentioned on the screen. So all these directions come on screen, then you have to kind of you will look at all the 4 points on the screen. Then the sensor would know how your eye moves. So this calibration process you have to do for every user before every session they interact with your computer. So that will specify your screen size, and then your identification of pupils by the sensor. So that has to be done for every user before everything. Yes, after that. Yes. that then, yeah, because in the calibration it is the sensors, they capture the normal eye thing, so in the beginning when I'm giving you some instructions, it will not show any emotions, right? That will be neutral stage for you. So they capture the neutral stage. Okay, once if you come to my lab for the study, and we will give you the laptop where this eye tracker will be mounted already. So we will start calibrating for you. So when I'm giving you instructions, okay, now follow the instructions on the screen, you will just read, you will not show any emotion at that point. So generally people don't show emotions when they are new to something. They are just curious to know. So at that time the neutral data set is captured, and all other things we can we can compare it to that neutral data set. And it is like a way of telling the sensor where your eyes are and how your eyes are moving. What is the tendency of your eye? Are you kind of moving from one position to slowly next position, or you're just blinking one position next position? So that tendency is also getting captured during that calibration process. So generally when the calibration is to a good level, then the eye capture data is the captured data is of good quality, considered of good quality. Hmm. So I see there's a lot of confusion regarding this micro and macro expressions, macro features, I think, yeah, not expressions, if I'm not wrong. Yeah. So you don't get confused with macro and micro, because first of all, we don't want to go into any of the machine learning algorithms. So generally deep neural network or recurrent neural networks are used to train the model for this frame by frame detection, because every frame, the facial expression data, for 1 second there are 25 frames getting captured. So that means even if the interaction is happening for half an hour, we kind of have a huge number of frames. So we have very very large data which is in images format. So images are stored in the pixel format, so every frame will have kind, even if it is non HD, it will have so many pixels, 856 by 856. Yeah. So micro features, yeah, I'm coming to that point. So micro features are what is the individual value of each pixel in that frame. So even if you don't want to consider background, or if you don't want to consider lower body, you want to consider only the face, then even the face features, every pixel value will be like too much of the data. So that is micro feature, where you go into the detail of the image to get the individual pixel value of your frame. That is micro feature. And macro feature is when you consider the averaged out value. You're like, okay, you will specify that this was the pixel, like when I raise my eyebrow, the pixel value will change. Or if I kind of look like this, the pixel value will change. So those are, the average value will also change, the average pixel value. Features or expressions, because I think this is, so these are features, what I told you are micro and macro features. So about hmm hmm yeah. Yeah, you can call it that also. I mean, yeah, I'm not sure. No, trackers will not be able to do it. You need to have a complete image data. So the facial expressions, the webcam captured frames, using that you can do it. Not with the eye tracker. Eye tracker will not capture. What eye tracker captures is the coordinates where your pupils are looking at with respect to the screen size. That they capture along with the timestamp. At what time the eyes were at what position. That is getting captured in eye tracker data. And using those coordinates, you are mixing two things, like eye tracking is different and this expression is different. Like, you need to keep them separate. So now you tell me, what is your doubt regarding eye tracker or regarding facial expressions? Yeah, you can. I think I'll advise you to read more about what are actuation unit AUs. I think that link should be part of the. Yeah, yeah. So there you will get more information and accurate information, because while telling, I may not use the proper correct word. Right now I explained you what are micro features and macro features, but not expressions. So so some words might be here and there. So I'll advise everyone who have this doubt about micro features and macro features, read about actuation units. How these 9 actuation units are assigned to different facial expression, like different regions of our face. The eyebrows, the eye movement, the lips movement, and all those things, how they are decided. So read more about actuation units. Yeah, the blog link should be yeah, it will be given, I think. Yeah. So it will be easier, like if you read through that blog, then things will be more clearer. There won't be any confusion. And for now, like for sake of understanding, you can say that every actuation unit considered together will help us deduct what emotion state a particular person is going through when we consider their facial expressions. Because every emotion, not you can't tell if I'm happy or sad just because I'm raising my eyebrows. You have to consider other portion of my face also. Yeah. So you can consider macro features and micro features together, for this purpose. For a particular region, what is the particular region of your face, what are the values based on that. And same goes for expressions also. So general expressions. So I'm really not, I'm not clear about micro expressions and macro expressions, so I will not go there because I don't want to confuse you. Yeah. 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 So coming back to this eye tracker data, so what eye tracker does is, with the timestamp, it will capture the x and y coordinates where our pupil is looking at the screen. So based on that data, we can actually decide value for these following list of features. Okay? The average fixation count. Fixation is when you are staring at something. If there is for this particular information on the screen, there is a table. So maybe I am fixating on that table, I'm continuously looking at that table. So that is fixation. So fixation count is total number of fixation, how many times I constantly looked at whichever content in that page. So that gives us fixation count. Then fixation duration, so for how long I was looking at a particular coordinate. So that will give the fixation duration. So how we get the duration? Because every eye tracker data has the timestamp. So depending on the timestamp, we can calculate the fixation duration. Then no, fixation is when you stare at something, when you fix your gaze to something, that is fixation. Gaze is like when you move your data, when you're moving your eye gaze. So yeah, gaze or eye gaze is like the path which your pupil is following. So fixation is when you look continuously at a particular point, that is fixation. So what you're saying gaze, another word is sakat for that. Sakat, amplitude, the movement, the continuous movement of your eye. So what happens is, our eyes are not continuously moving from any point to any point. So there are some some starting point, some end point, and then there is no continuous movement. So continuous movement is sakat, but that continuous movement also happens in pieces, in bits and pieces. It is not always continuous. We might look away from the screen and then come back to the screen. So for the moment when we are away from the screen, that data will not be that data will not be there, because we are out of the limit for that particular sensor. So that thing also we have to, the continuous gaze is sakat. So what you are referring to is sakat. Then fixation count on AOI. So AOI is area of interest. When you want to analyze, like in say other domains like advertising and targeted advertising, or when you want to analyze your GUI. So for that purpose, you will see if a particular image which you have put in your page, or particular advertisement you have put in your page, then how many fixations that is getting. So that So for that purpose we have to first fix the coordinates of our area of interest, and we have to see how many times the pupil reached to those coordinates. Yeah. Then average fixation duration on a particular area of interest, or AOI. So same way, difference of timestamps will give us the fixation duration. Then relative saccade angle in degrees. So saccade angle is continuous movement. So if I am moving from left hand side of the screen to right hand side of the screen, then what was the angle, relative angle? If this was 0 degrees, then when I reach to the other end of the screen, what was the angle? So that is relative angle. Then saccade amplitude is again how much degrees or minutes of arcs of this thing is measured. Okay. So to answer question in the chat box, will the eye tracker measure the pupil dilation? There are some advanced eye tracker, they also measure the pupil dilation. So how do they do that? Because we are tracking the pupil eye movement, as in pupil movement, where our pupil is looking at. So it also has some kind of assumption about size of our pupil. So when that size changes, the advanced sensors, they also make note of change in size. So that will give us the pupil dilation information. So some advanced sensors, so there are wide range of eye tracking sensors. They kind of cost from few thousands to few lakhs. So as you go on to advanced sensors, they'll give us more information about eye movements and eyes in general. Yeah. Some of the eye trackers, the advanced eye trackers, they also capture periodically, they also capture images of our eyes. Like that is something really, I mean, really advanced. Yeah. So I think I'm done. We can move on to the questions, and we will tackle the doubts as we go along the questions. So my advice from exam point of view about this week would be, don't worry about much, because there is no questions about any practical applications. So you just get to know different sensors. So when you want to conduct your own experiments or your own on research studies, for that, if you want to kind of use a particular sensor, then at that time you can take help from internet to learn more about how to use this data. So for now, this is like just for your information. Okay, these are different sets of sensors. They capture these sets of data, and that can be used to deduce this information about the learners. Okay, so if you're not very clear about how each and every sensor is working, that is fine, even for exam point of view. Okay, so you can, as and when needed, you can go into detail, dig deeper into particular sensor. Okay, so moving on to question 1, which of the following sensor is or are used to measure learner stress? I think we discussed this. So you want to answer in chat box about which sensors are getting used to measure stress. So I'll give you hint, there are multiple sensors from ABCD. There are more than one sensors. EG and GSR also. No, GSR also. Because GSR, what it will do is, when we are under stress, our skin will have some minute temperature changes, and some minute sweating also, which normally we will not be able to feel, but that changes the the electron carrying capacity, or skin conductance, which is commonly called as. So this GSR sensor, they will measure the skin conductance as well. So we can link the GSR output to the stress level of learners also, the emotional arousal level or stress level of learner also. So even GSR is used and EEG is used. No, not. Motion sensor is generally the physical sensors. Sorry, you're not audible. You're done asking? Okay. So motion sensors are generally the physiological sensors, or different kind of sensors which will work on different principle. As you enter a room, a motion is detected, a temperature change is detected, and then, so motion sensor we really don't use motion sensors for learning analytics purpose, but we would use motion detection or posture detection, to be precise, not motion but the posture detection, how our neck is getting tilted or how hands are getting moved. All those things will help in inferring something about learning processes, but not the motion sensors. Okay. Yeah. Okay, so moving on to question 2. Which of the following features can be extracted from data collected using an eye tracker? So this should be easy. Area of interest, fixation sequence, time spent, and revisits. Fixation sequence. Okay, there are multiple answers to this question. Yes. Yes, time spent also can be. And what does your common sense say? Do revisits will also be captured? Can we detect revisits? If I'm looking at a particular content or a particular row again and again, will that be captured? Yeah? Yes, so all the answers are correct. Okay, all the options are correct for this question. We can capture everything like areas of interest, fixation sequences, then time spent, and revisits also. Then coming to question 3, this is how the heat map of eye tracking looks like. Okay, so generally the red is values to more, the count is more on the red region, and it slowly decreases from red, yellow, green. Yeah, so this is the eye tracking heat map. So what does it represent? So yes, I kind of gave away the answer when I tried to explain what red color and what green color meant. So yeah, descending order of amount of gaze points which that were directed towards whichever part of the image. Yeah, so this heat map is not the output of the eye tracker sensor, but eye tracker sensor output is in the form of a log kind of sheet where your timestamp is there along with the x coordinate and y coordinate of pupil. Yeah, so based on that information, this heat map is generated. So going to question 4, match the following with correct pair. So this also I think you can answer rather than me giving answers. So can GSR, right? Okay, great. Microphone and brainwaves EEG, right? So which option? D. 1C, 2D, 3A and 4B. So D. Okay. So moving on to question 5. What is effective computing? And so we have to select only one option here. They have given select only one option from the below option. C. Everyone agrees that the C is the correct answer? Right? Everyone, we are on the same page that C seems to be correct answer for this. Right? So we'll move on to question 6. Yeah. So these were the points when I was talking about macro and micro expressions. So these are different actuation units with the image, corresponding image. And so according to the facial action coding system described on iMotion's blog, identify best emotion that suits given sequence of facial expressions and corresponding action units. So when so we have to match these facial expressions to the emotion which when you consider these facial expressions together, what emotion this person in the image is showing. So first photo we will look at is inner brow razor. Yeah, so even the eyebrow sadness, we have to consider 1, 2, 3, 4 together, not just 1 or 2. Okay. So I saw, yeah, there is single answer correct. Yeah, there is single answer correct, because in computation or when we are detecting any emotion, it's better to consider only one emotion which has the highest probability there. Yeah, so you have to answer from that point of view, which emotion is of highest probability. Yeah, Shrinanda, you're saying something? C, surprise. Yeah, so Bijoyji is also saying surprise. Nivaji, what do you say? Which emotion? I see couple of B's in the chat box, and one C. So let's B is sadness. So Shreya, if you consider all the four images together, do you still want to consider sadness option? Okay. Disgust. Okay, we have one interesting answer. Okay, so okay. Yeah. Yes, agreed. Kappa would be really low for, I think, options other than C. I think for C we have maximum agreements. We have couple of sadness, we have one disgust, no happiness, and no fear and no anger for sure. Okay, so let's try to understand. There is eyebrow raise for sure. Slowly the eyebrows getting raised. First it was inner portion of the eyebrow raised, and then the outer portion of the eyebrow was raised. Once that eyebrow raised happen, even the eyes, the size is bigger. Upper eyelid raised, the third image in the sequence, like this image. Okay, so this inner eyebrow and outer eyebrow together considered, then it will give us eyebrow raise. Yeah, both together eyebrow raise. But now eyebrow raise to such an extent that it even made eyes look bigger. Not just there, it went one step beyond and made eyes look bigger. Upper eyelid raiser, the eyelids, the upper eyelid, they raised. Okay, so we can say that eyes appear bigger, and jaw drop. So this happened. In smile or laugh or happiness, what happens is our upper lip, that area goes up, so that our cheeks are also, shape change happens. But here that is not happening. What is happening is jaw drop. This jaw or the lower lip area is coming down like this. Yeah, so now when we are scared, do we raise our eyebrows always? So Shreya is saying that it would be B, sadness. Yeah, so when we are sad or when we are not really happy, do we raise our eyebrows, or there'll be a droop in the eyelids? Yeah, when we are sad, probably how my eyebrows are right now, like that, maybe that would be shown by majority of the learners. But when we are raising our eyebrows, making our eyes big, will that be associated with sadness? Do you agree, Shreya? I want Shreya to give answer, because we need to convince her to increase our kappa score that it's not sadness. Huh. Right. Right. Agreed. So maybe the confusion is because this pictures are in the part. They are not a complete face. If they would have given the complete face, then probably this confusion wouldn't have been there. Because when we look at somebody, so if all your videos would be on, then probably we would be able to see Shreya's confused face, and we would be all of us would be telling her, this is how your face is looking like right now, and it is not surprise, or it is not happiness, so it is mainly confusion or frustration, so something like that. Yes, consecutive frames. So when what happens is, when our emotion changes very rapidly, any emotion is displayed only for maximum 6 seconds by our face, like maximum 6 seconds. It changes within the fraction of second. So that's why when we are capturing 25 frames, There are web cameras which capture the images. There is no tracker for this. There are web cameras, so these are images, these are getting captured by the web cameras. Yeah, so what is happening in a second, this happens, so any human being will not keep this same expressions for more than 2-3 seconds. No? So that's why what we do is, for each seconds, those 25 images we have, so we have to consider them in a sequence. So even though I'm doing this is happening when it is getting captured by some video camera. There are so many images which are getting captured in that 1 or 2 seconds when this eyebrow raise happened and the jaw drop happens. So this is we have to consider those 1 or 2 seconds mein how whatever number of frames is there, we have to consider that to detect the emotion based on just one picture, one photo, which is like this emotion detection is happening like as and when the data is getting captured, right? So based on one image you can't do it. You have to consider series of frames which are getting captured by this webcam. Okay, so that's why these may not be having the same timestamp. There will be a 1 microsecond or 2 microseconds gap between these images, so that's why I'm like, you have to consider them sequentially together to tell which emotion they are saying. So when they say inner brow raised, so when you look in front of mirror and then you see how your eyebrow raise happens. So you first raise this part and then you raise the outer part of your eyebrows, and if you raise it any further, your eye size increases. So this is what is happening. And now we are done with the the motions of eyes, and now coming to the lips expression. So the jaw drop happens. Again, I gave you expressions that when we smile, you have to kind of observe yourself in mirror. When you smile, what happens is your cheeks are this bone, this jaw movement doesn't happen. Your muscle movement happens when you're happy. Yeah? And when you're sad, your lips droop, not just your jaw. Okay, when we are sad, this will happen, the lips are tightly pursed together, they are not separated. We generally don't show our sadness with our mouth wide open, right? I'm sad. It doesn't happen. We will just keep our lips pursed together when we are sad. Yeah? So this emotion, when the jaw drop is happening, going by English literature inferences, when the jaw drop happens when we are surprised. Yeah, so this jaw drop was a giveaway for emotion of surprise, option C. So why this is not sadness? Because we don't generally drop our jaws when we are sad. Okay, when we are surprised by something, then only this jaw drop moment will happen. Okay, so Shreya, are you convinced or you still want to choose sadness? Waiting for your answer in chat box. No? Am I audible? Okay, she's not answering, so that's why. Okay, great, she answered, her answer came back. Okay, so we'll move on to next question. Yeah? So we have this data which is captured by eye tracker, and we have to answer 2 questions based on this data. So as I was telling you before, like x coordinate, y coordinate, and respective timestamp, we have to that gets captured by eye tracker data. Okay? So you will note that for set of some 5 timestamp data, the y coordinate is common, and for next 5 the y coordinate is common, and only the x coordinate is changing. Yeah, looks like reading, right? So yeah, that was very good conclusion. It looks like reading because this is y and this is the x-axis. So when we read in a row, our y is going to remain constant and our I is moving across the x coordinate or across the x-axis. Yeah? So this looks like the reading, the eye tracker data for a reading task. Yeah? So let's see what kind of questions are getting asked. From the above table, long saccadic movement occurred at which timestamp? So saccade is change in both the saccade is continuous movement, so when this is one saccade and this can be another saccade, because one coordinate is fixed and our eye is moving across, so which was the long saccade? What are the time stamp where it is getting started? No, why? At these so at 2:22 this change of both the coordinate is happening. There is a movement, there is sudden movement, like change of both coordinate is happening. The gaze is changing, the gaze pattern is changing, and now it is again continuous motion because y coordinate is same. Yeah, so which timestamp would be where the long saccade is starting? This. Everyone agrees that. Srinanda, you want to say something? So I explained, why there is this continuous motion, because x coordinate is same and x coordinate is same. So saccade will begin when it will begin when there is a change in both the coordinates, right? So the transition between one saccade and other saccade is happening at this point. Yeah, so this will be the answer. It's very intuitional kind of thing, so at this point one saccade was beginning at this point, at 1 microsecond where it was this first, and then it went all to the 5.8 on the same x coordinate, and then the eye gaze came down to this particular coordinate, this set, and it went on to this set. So this is first saccade and this is second saccade ka starting point, but in our option we just have this, so it is option D. Okay, so moving on to next question. From the given table, what could be the possible action performed by the user? We already kind of deduced this. What was the action? Okay, yeah, no problem. So the question was, when was the long saccadic movement happening based on that table data? Okay, so we kind of explained saccadic movement is continuous movement. So here the one continuous movement is happening because y coordinate is same, right, for all these 5 data. So first saccadic movement is beginning at the very starting point, and then the at this particular timestamp 2 minute 22 seconds it is changing the coordinate, both x and y changed, and then the y coordinate remained the same and x value only changed. So there is a continuous motion here. So this was the second saccade, and this was the second saccade starting point, first saccade starting point. My internet connection seems fine. Is this lost for everyone? Okay. Okay. Not sure what could be the reason. It's audible. Okay. Yeah, so maybe some internet issue at your end, it could be there, no? I'm not sure. Yeah, anyways, I'm explaining what you already heard. I'm just repeating that this was the starting point of first saccade and this was the starting point of second saccade. So out of these two timestamp, only one seems to be in the option, so that's why option D is the answer. Yeah, now it's fine. Okay, yeah, so would be some internet issue from the other end. Yeah, because let me check again. Yeah, my internet seems fine. Okay, but it's good practice to let others know that you're not able to hear, or there's some problem. So if there is problem at my end, I can be more vigilant. So So we were on this question, what kind of action could possibly be performed by user. So we already did it when we first saw the table, what kind of action it could be. So somebody gave answer to that question. Reading, yes. Yeah, because y coordinate is constant and x is changing. So if this is like y coordinate and this is x and we are reading, so only the x coordinate is changing and y remains the constant for that particular row. So reading action is getting performed here. Coming to question 9, what is the major challenge while collecting data from different sources? Yeah. So analyzing data from each channel, combining and syncing information from different modes, pre-processing the data from different sources, and getting consent from participants. So what do you think would be the correct answer for this question? There is only yes, combining and syncing information, because every sensor will have its own way of capturing data in raw format. Say for example, eye tracker timestamps are absolute timestamps, just like here when we saw in this table, these are not system data stamp, these are absolute data stamps. So eye tracker captures data stamps like that. And there is another set of sensors called iMotions. So iMotions will sync data capture with the system time, and our log data will have timestamps of server, where the server is. Yeah, so every data source will have data stored in different formats. You can't just club everything together. Eye tracker is capturing x and y coordinates, while GSR EEG are capturing our skin conductance and that information. So mostly it is represented as graphs or other things. So you have to find where the peak is happening or where the dip is happening. So all those things you need to note, and that would be the pre-processing of that data. So every data has different set of actions to be performed on while pre-processing and while deducing. You can't just combine all the raw data together and make conclusions. Like you have to generate your features like emotional state or stress level or cognition level and all those things. So that's the major challenge why not too many channels or too many modes of data are considered together while doing this learning analytics, because then combining and syncing that information with the log data or with the other modes of data like video data, it is very difficult and remains the open research problem or open problem to be solved in the field. So coming to question 10, these are the two advertisements. So what inferences can be drawn from respective heat maps? So we have already seen the what is the meaning of red, yellow and green in the eye tracking heat map. So Shreya gave answer option D. Option D for this particular question, Shreya, or question 10? What is your answer for option D? I did not get it. Okay. So going to question 10, from this what inferences we can draw? Yeah. So let's look carefully at both the images and now read the options. Okay, option 1 says advertisement 1 receives more attention than advertisement 2. Then going to option B, fixation time on brand names in advertisement 1 is shorter than in advertisement 2. Yeah, so this is the second image. This area is the brand name. Here is the area of interest for us. This is the brand name. Okay, so now you have to see how many fixations are happening here. Then let's read option C. The text in advertisement 2 receives almost no fixations because of its smaller size. So this we are drawing inferences. That's why we can establish this thing, because of its smaller size, it may not have been receiving more fixations. So here is the text data on this side of the image, so you have to map this and make your conclusion. Now last option D, text in advertisement 1 does not receive fixations. So you have to see where is the text part in advertisement 1, and you have to see if it is received any fixation. You have to map this text to this heat map. You can see here also the text behind. And now you can tell me, there could be more than one answer correct also, Shreya. Yeah. So A, B, C. What makes you think A? Why you think A is correct? More reds. That means their fixation count was more for A. There are more red. Okay. So A seems correct. Why B? So is it receiving more fixations, brand names? If fixation time is more, that means wo red area will be more. Yeah. So this red box is the brand name here for advertisement 2. Yeah. This is advertisement 2. This is advertisement 1. One is shorter. One का brand name यहाँ पे है. ये brand name है. So there is red. इसका brand name यहाँ है. Is there any red here? Is there any red dot here in this area? Which second image? Lal wala box is brand name. I have written over here, na? It is brand name. That red box is brand name. Because these are not Indian brands, so we should know that which is the brand name in this text of this advertisement, right? So that's why this second image was deliberately added. This box is our area of interest or brand name. Yeah. If you see, sorry, these are different advertisements. And first is how the first image in both the cases, there are 3 images for 1 and 3 images for 2. Yeah, so image 1 is how the actual ad looks. Image 2 is our area of interest mapped, which is our brand name. Yeah, so this green box here and red box here for advertisement 2 is the brand name marked. Then in image 3 is the actual heat map generated based on the eye tracking data, right? So you can map, मतलब heat map देख के you should be able to conclude. Yeah, C also seems to be correct. Text in advertisement 2. But why, like, I want Srinanda to speak up. Why B is right? Not correct. Okay, yeah, now you're convinced B is not correct. And option C, what do you think about option C? C is correct. Okay. But now you're convinced that B is not, because see, there is this brand name area of interest. There is this red thing happening here, na? There is this red dot for heat map. That means there are many fixations happening. The fixation count is very high for this square, no? But whereas if you consider this advertisement 2, it is just yellow, it is not red. That means for brand 1 it is higher compared to brand 2. So this statement is not correct. But C is correct. So it is A and C, not ABC. So red, yellow, green. Red means high. Oh god, okay. We have already done this. I was not expecting this question again. Okay, let me go here to this question. Okay, so this seems to be a better example because there is no confusion of 2 images. So this is how this heat map is number of fixations happening to a particular part of page. Yeah, so when that count, fixation count, that means all the users are looking at one particular point, that gives the fixation count. How many times did I use? So yellow color means higher number of fixations happening at that particular area spatially. Okay, so this is our area of interest, entire paper. Huh? So in this paper, at this particular point, most number of people were staring, yeah, looking constantly. So fixation is looking constantly. So how many people looked constantly in a particular area is fixation count. So for all the people, we will combine that count, or even for a single learner, we might again and again look at a particular point, right? So how many times that fixation happened, so that will tell us fixation count. So that count we will map on this page specially, which is also known as heat map. So when the count, that fixation count is higher, that area will be red, those coordinates will be red, no, because we'll have timestamp and x coordinate and y coordinate with us, yeah. So how many times this timestamp is repeating, that will give us the count. So that count is higher. When that count is higher, this, for that particular x and y coordinates, this area will be red. And as the count decreases, this is the gradient happening over here, the highest number will get the deepest shade of red, and from red to green it is transition. So yellow is somewhere in between, and green is lesser number of fixations happening. And there will be some fixations we will not consider. So that's why the fixations are not all over the place, because not every corner of that screen will be looked at, is not getting looked at, yeah. So this is how this heat map is generated, yeah. So we have nice explanation in the chat box also. Red color indicates the highest. Okay, yeah, I will post it once again. It's a very nice explanation. So red color indicates the highest level of attention or interest from the viewers, while areas with green color indicate the lowest level of attention. So the same thing I said, so I will be repeating again, because since you said you got disconnected. So red points, red coordinates are where the maximum number of staring happened. So we will count this timestamp and x and y, how many times it has happened. So fixation count will be higher for certain x and y coordinates. So there this red will be plotted, red color will be plotted for those x and y coordinates on our screen. And for lesser number, as we go down, lesser and lesser, we go to the yellow and green. So it is in descending order: red, yellow, green. Yeah, okay, great. So I think you joined in late, because this was question 3, and yeah, we kind of did this during this. Okay, no worries. I think now it's clear, I hope. Today a lot of people seem to have internet trouble. Okay, yeah. It is just comprehension. It is like picture comprehension. How do you solve it? Is like picture comprehension. Area of interest is given. You have to see maximum number of saccades, matlab red color. Where is the red color happening? And there is no color, that means there are no fixations happening in that particular area, So when we consider option C, for example, the text in advertisement 2 receives almost no fixation. So is this which area of advertisement 2 is text? This right hand side area, this portion, let me change the color, yeah, this portion is the text area. You can see, right? This is the text area. So is there any red, green, yellow here in this portion? No, so there is no fixation happening in the text area. So that means option C is correct. So option D says text in advertisement 1 does not receive any fixation. So now you tell me, isn't this the text area of advertisement 1, which I just marked with yellow color? And you have to map this with the fixations happening. So there is some green, yellow here. Here there is red color, capture nature and other things, this SMS things, all those things is receiving some eye gaze, right? There are some fixations here happening in the text. So that means this statement is not correct. It does not receive fixation, is wrong. And option B, consider fixation time on brand names in advertisement 1 is shorter than advertisement 2. So brand name is here. This is our area of interest. This is the brand name here for advertisement 1. This is the brand name for advertisement 2. So you have to see, are there any red dots here? Yes, there are. So there is good amount of fixation happening in brand name for advertisement 1. Are there any red dots here? No, but there are yellow. That means which is lesser than this, because here there is red, but here there is no red. It is yellow. That means for advertisement 1, the fixations are more as compared to advertisement 2. And if the question, if here also there would have been red color, then you would see the size of that red color. Bigger the red color, that means more fixations happening in that area. So it is. Yeah, red, yellow. Red means highest, green means lowest level of attention, and no color at all means no attention at all. I think we solved question 9. Yeah. Yes, absolutely correct. Because it may not happen na कि our fixations or eye gaze are always happening to entire portion, entire area of interest. So when I'm reading or when I'm going through something, so for example, let's say scrolling through Facebook on your laptop. So there is a feed coming in between, so you will be looking at that area only and not your other open tabs or other portion of your laptop screen, right? So that means our area of interest is limited. That area will only receive our eye gazes. Rest of the screen may not receive any eye gaze at all. So this is what happening. When there is no eye gaze, there is nothing to map against that area spatially, right? Spatially as in pictorially. Yeah, so that will be blank. So when we are overlapping our number of fixations with our actual image, that there will be nothing. Like here there is nothing, no color. Yeah, but whenever the fixations are happening, there is green color. This one? Hmm. Hmm. So when I was explaining this, I specifically asked to consider this sequentially, like 1, 2, 3, 4 together. You have to consider, not individually. Yeah. So when such questions will come in the exam, you have to consider all these expressions together. You have to club it together and then think about what could be the possible, what for which emotion the probability would be higher. So when the jaw drop happens along with eyebrow raise, it is not sadness. When we are sad, we don't raise our eyebrows and we don't drop our jaws. When we are surprised, this is the general facial expressions of human beings. When we are surprised, we will raise our eyebrows and will open our mouth. But when we are sad, we will not open our mouth. We will not be raising our eyebrows. Yeah, we'll be keeping our lips together. The process of raising the eyebrows, when you observe, you stand in front of mirror and you observe how your eyebrows are getting raised. So these three pictures represent the process of eyebrow getting raised. So eyebrow raise, just inner brow first raise hota hai, then outer portion of our eyebrow will come, and then when you stretch it further, the upper eyelid, this upper eyelid will be raised. So it is like this, no? Hey yaar, this I explained 4 times already, Ray. Hey, what man? What is there not to understand? These are just x and y coordinates. Forget about eye tracker or everything. It is just x and y coordinate. So this y coordinate is constant. Yeah, that means our eye is moving slowly. There is a gradual movement. So saccade is gradual movement. So first saccade is happening from this point, no? First second, and now here there is another set. There is a divide, you can clearly see यहाँ पे x coordinate is same, this is x coordinate is same, y coordinate is changing. So that means this is the second continuous movement or second saccade. So this is happening at this time stamp 2.22. So out of these two answers, only one is part of options, which is option D, 2.22. Yeah. So yeah, Bijoy ji has mentioned that facial action coding system visual guidebook mein there is a chart given which expressions considered, like which photos to consider together to deduce which emotion. So that will be a good preparation point, So Bijoy ji, coming to question 9, what are the major challenges? So what is exact confusion here in this? Because this challenge has been addressed in the lecture video also, that combining and syncing of information from different modes. What is the confusion? I would like to know more so that we can have a specific discussion about that. You can unmute and talk or type in the chat box, whichever is suitable for you. Hey man, this is very... this is simple reading while looking at the table. You only told me, this is reading action because y coordinate is simple. Yeah, you only told me. I remember you only deduced that this seems like even before the question came. You only said it's reading action. Okay. Yeah, I'm surprised because it coming from you, Nevaji, because you only said, I remember correctly, you only unmuted and said this looks like reading data. Yeah. And even if you're missing, even if connection is getting lost, this recording will go up on YouTube for your information, and all the links are shared with you all through the Swayam portal. Okay, I repeat this every week almost. Don't panic if you're missing any question. You can always go back to the recording which will be uploaded on YouTube. Yeah, and you can access it at the end on your left hand side column. At the end there is this problem solving session wala tab. If you go on, there is a link to Excel sheet given, and that Excel sheet has links to this PDFs also which I use, and to YouTube videos also. So even if you're missing anything, you can always go back and go through the explanation of whatever question you want. Yeah, so don't get paranoid if you're missing anything due to bad internet connection or missing a particular session. Don't worry about it. This is like open access for everyone. These sessions are like, for those who are not able to attend this session, they can have access to it. So Bijoy ji, are you there? Yeah, you are there in the meet. So why are you not asking like what question you want to, what point you want to discuss for question 9? I'm actually waiting for this thing because we kind of discussed this when we were discussing this question, why combining and syncing information from different modes is a challenge, because every sensor will have its own way of capturing data. They will capture different information, so that raw information you can't club together. You have to convert it into some features and some uniform timestamps to combine it. So it's not easy, it always becomes challenging. So when you have, even if you have log data and the screen capture data, you can't really map the screen capture video data with your JSON log data, or even if you convert that JSON into table format or CSV format or Excel sheets, then how you will map Excel sheet ka data with the video data, the screen capture video data, the image data. So it always remains challenge to combine different modes and different channels of data. compared to that, other tasks are also daunting, but they are not as difficult. If we put in a lot of efforts, we can do it. But combining some raw data in different formats, in different which have different features, to combine them together is a challenging problem. That's why option B is most challenging. I mean, yeah, it's like most difficult task of all the options. So for more information on affective computing or this thing, emotion detection using facial expressions, please read iMotion's blog. Okay, linked to that blog is in lecture slides. So please go through that. If you have any confusion about how to detect the emotions through different action units or actuation units, so that detail is mentioned on iMotion's blog. Yeah, so there are different, how many action units are there, how many AUs are there, and how each AU is helpful in detecting which sets of AUs will give you a particular emotion. So all that is given on the iMotion's website. Okay, so if there is any confusion, please read the iMotion's blog. Okay, and if there are no more doubts, we can conclude today's session. Okay, so thank you all for joining. We'll conclude today's session. So next week will be the last week. Yeah, last week of the course. So all the best for exam preparations. We'll meet again next week. Okay. Yeah, and don't worry, don't get paranoid if internet connection is lost or you have not. Yeah, I mean, if there is any other way, the links to this sessions is always provided, it always accessible to you all. So don't get paranoid if you miss some part of the session. Yeah. Okay, so ending the session for everyone. Yeah. See you next week. Yeah.